All right, so this recording is going to cover section 9.3, and this is continuity or continuous functions. So, what does it mean to be continuous as a function? So, look at our definition here. It says a function f is continuous at a specific point if the limit exists and the value exists and they're equal to each other. So until today, we've been talking about that limit. What is the limit at this specific number? Like, where is the function? What's happening from the left side? What's happening from the right side? Now we care where that value is if we have that open dot or not. So if I was to draw, let me draw like a little graph right here. Oops, there we go. Ooh, that's really thick. Here's our X, here's our Y, right? And if I was to draw a graph that kept going and then it stopped, had an open, and then continued or something like that. And this is at 1, we'll put that at 2. If I looked at this graph like this, it would not be a continuous function because there's a break in the graph at 2. It wouldn't be continuous at 2, I should say, if I'm specifically looking at 2. Now, the limit would exist, though, but the value part wouldn't exist. So we do have to look at that a little bit, looking at the value and looking at the limit. So that's what this whole section is about. It also is solving something that kind of seems a little bit different, but we'll get there. So here's our properties. This is just basically saying, like, property 1, a constant function is continuous for all x's. So if your y equals or your function equals like 3, then it's just going to be a horizontal line at 3, and you're just going to equal that, and it's continuous. Part 2 says for all positive integers, it's continuous everywhere. So if it's an x or an x squared, x to the third, x to the fourth, we've all seen those graphs. It's continuous. There's no holes. Okay. When we start looking at, so all polynomials are continuous. Okay. A rational function. So basically, if you have an x in the denominator, you have holes in your graph or asymptotes, right? So then there's spots where that could not exist. Now the holes are really hard to see in Desmos, and that would just be, a spot that's open on your graph. You have to actually like move the little graph on Desmos right on that spot, and it'll show it's undefined. So not super easy to see. But that's when we start to get the weird ones, right? If I have an x in the denominator, I'm looking at square roots and some logs. That's when it's not necessarily continuous. That's what that's talking about. And then the second part is talking about constructing sign charts, which I will just show in the homework. So let's look at this first one. In problems 1 through 5, using the properties of continuity or continuous functions, determine where each of the functions are continuous. Okay, so look at this. It's an x to the third, x squared x. This is a polynomial. Where is this continuous? Everywhere. It's always continuous according to our rules. So it's continuous from negative infinity to infinity. So infinity to infinity or everywhere. It's always continuous. Look at problem 2. Where is this continuous? Well, we have that denominator. So we got to look at where that denominator equals 0. So x squared minus 9x minus 36. Where does that equal 0? So we can look at factoring. So like, what multiplies to 36 that would add to 9? Well, it's not 6 and 6 because those don't add to 9. Oh, it's subtract 2 or subtract. So 12 and 3 12 times 3 is 36. So that one's going to be the one that would subtract to 9. And we want this one to be negative because we want it to become a negative 36. So that's what we're going to use. So we're going to factor this into x minus 12 and x plus 3 equals 0. So we're going to have two spots on our graph where it's not continuous. And that's going to be at x equals 12 and negative 3, right? Opposite signs, or where they equal 0, right? So you could state this in interval notation, and it's kind of ugly. You go from negative infinity to this negative 3, don't include, so we use the round bracket, union that with negative 3, don't include, and go to the 12, don't include, union that with 12 to infinity. So that's how I write it in interval notation. Okay, number 3, where does this denominator equal 0? So x squared plus 3, where does that equal 0? Well, if I minus the 3 over, because I could try to factor, but it's not factorable. Or you can solve it this way. Where does a square equal a negative? It doesn't. So this doesn't actually equal 0, so it doesn't have a hole in the graph. So this is no solution. I don't know how to, that's just a quick, easy symbol, right? And so this one is all from negative infinity to infinity. It's continuous everywhere. Number 4, it's an odd x square root, not square root, square is 2. It's an odd root because it's a third, right? Where would that one, the third root of that, where would that be continuous? Well, we don't have to worry about that negative in the denominator because it's a third root. You can get a negative. So this one is continuous everywhere. Okay, but number 5 is not continuous everywhere. This one, you have to be positive x minus 25 because it's a square root or a fourth root or a sixth root, those even roots. It has to be greater than or equal to 0. So we can just say, where does it greater than or equal to 0? Same way we do our domain. And then we could add the 25 over x squared equals or is greater than or equal to a 25. So then we have to take the square root and it's the positive or the negative. So x is going to be greater than or equal to 5 or negative 5. All right, so this one is our first one. We really would have to solve that with a sign chart because, okay, here's my logic. We have this negative 5 right here. I was thinking we didn't have to do a sign chart till the next one, but negative 5 and 5, I don't know which sections here, the numbers here, or the numbers here are going to be greater than or equal to. So how would I do this? Well, what I can do is I can do this sign chart and I just put in values that are less than negative 5. So maybe negative 6. Okay, and then I'm going to use this one here because it's just easier. So negative 6 squared, is that greater than or equal to 25? So negative 6 squared is 36. 36 is. So this section is a yes. It works. Okay, then we look at the next section. A number between those two would be 0, between 5 and negative 5. So 0 squared, is that greater than or equal to 25? No. So this section is a no. That's why I had to stop and be like, well, you can't just put negative 5 and 5. You have to know where in between each of those. So then the value above 5 would be 6. So 6 squared is greater than or equal to 25. So this section is a yes. So where is this continuous, or where are the solutions to this? The solutions would be from negative infinity to -5 and from 5 to infinity. So the problems start to be like this one at where they don't like necessarily say, where is it continuous? Well, I guess kind of. It has to be there. It has to be able solvable in between there. Um, so when we start to look at 6 and 7, I think those are the last two. So these last couple, you have to do, I call it a sign chart. It's a yes, no chart or whatever you want to do. Because you could do positive or negative, and I like yes or no because it's like positive means it would have to be, it is greater, right? Because it came out positive versus negative. But I like yes or no, either way. Okay, so problem 6 is going to be the same. Like, so notice the directions just say solve. They don't say where is it continuous. I know it's a little bit tricky. So we are looking at this one, and I have to see where is that less than 0. So I have to find those critical points or those areas that those numbers where it equals 0 to put on our chart. So we look at where does 4x squared minus 29x plus 7, where does that equal 0? And we call these critical points or something similar. So I could factor this one. So the way that I can do this is with the AC method, or I could do guess and check, but 4 times 7 is 28. So I'm doing what's called the AC method. So 4 times 7 is 28. Okay, the factors of 28 that would make -29 would be -28 times -1. These two would then add to that -29, but would then multiply to 28. So what I'm going to do is split up the middle term using what I came up with, which is -28, keep the x, minus x plus 7. So I use A and C to come up with what to break the middle term into, or any other factoring methods you learned. Then I use grouping, and I can go, okay, take a 4 and an x out of this one. I'd be left with x minus 7. And then over here, these are opposite signs. So I'm going to take out a negative, leaving this with positive minus 7. And then those two parentheses have to match. And then, so I keep the parenthesis that matches. And then the other one would be 4x minus 1, because it's like an imaginary 1 right here. And these are my two factors where it equals 0. So I have 7 and 1/4. Yuck. So what do I have to do now is a sign chart, which has 7, which is way over here, and 1/4, or 0.25. And then I still have to put in values and see if it's a yes or a no from here, here, and here. Okay, so something lower than 1/4, I would use 0. So I'm doing a little chart here, and I put in 0. So 4 times 0 squared minus 29 times 0 plus 7 is 7. Is that less than 0? No. 7 is not less than 0, so this section's a no. Okay, so a number between 1/4 and 7, you could use 1. I mean, you could use 2, 3, 4, 5, 6, whatever. So 1, because 1's easier. So 1 times, or 1 squared times 4 is 4. 1 times 29 is minus 29 plus the 7. Is that less than 0? Yes, because it's going to be negative, right? Okay, and then something above 7 might be 8. So I'm going to have to use my calculator for this one because it's going to be 4 times 8 squared minus 29 times 8 plus 7. I don't know if that's less than 0 or not. So let me just, 4 times 8 squared minus 29 times 8 plus 7. I got 31, which is no, it's not less than. So the only section that works for this one is, oh, and we could, no, it's just less than, so round bracket. 1/4 to 7. Okay, so 1/4 to 7. Okay, so obviously that's the only place that it would be continuous. Okay, last one here. You would have to include where it makes the denominator 0. So for our sign chart and where the top is 0. So we have to look at x to the third plus 3x squared. Where does that equal 0? And x plus 5. Where does that equal 0 to get my critical values to put on my sign chart? Okay, so this one up on the top here, I could take an x squared out, which would leave me x plus 3. Where does that equal 0? And I can see when I have the x out front, that's going to be a 0. And then this one would be a -3. So x equals 0 and -3 from this top one. Okay. And the bottom one is just -5. So on my sign chart, I'm going to have -5, -3, and 0. And then I have to do the same thing for this one. Okay, so what is less than -5? So still doing my little chart. And again, I'm just going to see where is it greater than 0? It's positive. So if you want to do that, you can. But I always do yes and no. Does it solve it or not? Because that's where that comes from. And the knowing if it's positive or negative confuses people whether it's greater than or less than. But that's why it's called a sign chart, is because most people do positives and negatives, but I say yes or no. Okay, so maybe a -6 is less than 5. Or excuse me, is less than -5. So I would have a -6 to the third plus 3 times -6 squared, all divided by -6 plus 5. And okay, -6 to the third plus 3 times -6 squared is a negative divided by negative. That's going to be a positive, which is greater than 0. So that's a yes. Okay, next number. Maybe -4. I think that's really the only one that's pretty between -5 and -3. So same idea. So I'm going to have -4 to the third plus 3 times -4. And I got -76 on the top, and then -4 plus is a positive. So I got a negative, which is less than, not greater. So this is a no. And then -3 to 2, maybe we'll try a -2. Let me see if I can pull that up a little bit. -2 or -1 would even be easier. -1's easier. So -1 to the third is -1 plus -1 squared plus 3 is, that's a positive. So this is all positive here. So this is a yes. And last one would be a 1. Is a 1. 1 squared, 1 plus that is 4, 1, 1, 1. It's all positive. So this is a yes as well. Yuckly, ugly. Okay, so you would be like, okay, from -infinity to -5, union that with -3 to 0, and then union that with 0 to infinity. Okay, so that's kind of ugly to write, but there we go. Okay, let me know if you have any questions on this.